Thank you all for coming. And today is the fourth meeting of the Cultural Evolution Seminar. We already had 3, and we will have one more meeting this December. So, and today we are very happy to have with us Dr. Alberto Acerbi, who is an anthropologist currently based at the Eindhoven University of Technology. Now working on a project titled Darwinizing Culture, the Status of Cultural Evolutionary Theory as a Science. Dr. Acerbi's work combines several strands of research, such as, well, anthropology, but also cognitive science, cultural evolution, mathematic modeling, and computational science, which is particularly interesting for us since our seminar also aims to be on the intersection of pretty much the same conjunction of subjects. So during his academic career, Dr. Acerbi participated in a lot of different projects and labs all over Europe, such as the Laboratory of Autonomous Robotics and Artificial Life in Rome, Department of Primatology in Leipzig, Center for the Study of Cultural Evolution in Stockholm and Bologna, and also the Department of Archaeology and Anthropology of the University of Bristol. So it should not be a surprise that his publications are dedicated to a great variety of subjects, such as the emotional expression in literary fiction, the emergence of leadership in autonomous robots, or even dog breed popularity. So also Dr. Acerbi actively takes part in the ongoing discussion about the role and form of cultural evolution theory, and for that reason I strongly recommend checking out his blog page. So if you're interested in cultural evolution but don't know where to start, this would be a great place to begin with. And the link is at our webpage and in the Facebook group and everywhere. So we're very happy to have Dr. Acerbi with us today, and the title of his talk is Selection versus Attraction in Cultural Evolution, 2 Empirical Cases. So let's welcome Dr. Acerbi.
Well, thank you very much for this fantastic introduction. I have to. There is a lot of people there. I will.
Sorry, we have some trouble with the sound.
Yeah, there is a lot of echo. Maybe I should. I don't know. Take my volume off, but then I will not know if you need to tell me something. Okay, maybe now it's better. Yeah, I just have some echo on my side. Okay, but should be fine. Okay, perfect. So sorry. Well, I was saying thank you very much for this very nice introduction, and thank you for inviting me to give this seminar. Also, congratulations for your seminar series. I think it's very important to do some effort to try to spread the knowledge about cultural evolution. As you were saying, I am an anthropologist, and in anthropology, very few people are interested or work in cultural evolution. So I'm happy to do my very, very small part in trying to diffuse at least the knowledge of what people in cultural evolution do. And regarding my seminar, I would like to start to this paper that I was writing a couple of years ago together with Alex Mesudi. Alex Mesudi, if I remember correctly, was he gave your seminar last week, I think. And in this paper, what we were trying to do, we were discussing a controversy in cultural evolution between 2 different approaches. One is the approach that we call the standard cultural evolution, and the other one is another approach that we call the cultural attraction. Basically, the standard cultural evolution is the classic approach in cultural evolution, is the approach that is linked to people like Rob Boyd and Pete Richardson, or Joe Henrich, or Alex Mesudi himself. While the cultural attraction approach is a different approach, more interested to especially cognitive aspects, and is generally linked to people like the cognitive anthropologist Dan Sperber. And so we were discussing some differences between these two approaches, and our main point was that that there is not a real contrast between the two ideas of cultural evolution, but they are interested to different aspects of cultural transmission and cultural dynamics. And we were concluding saying that in reality this debate is quite interesting and can generate some important ideas for empirical studies, and still today I think that this is true. And one thing that I still believe, and I think is very important, is that one of the key development for the next year of cultural evolution will be to integrate cognitive aspects in the study of cultural dynamics. I think these have been so far a little bit overlooked by cultural evolutionists, and one way to do it is, I think, to start from this debate and to try to do some empirical work. And this is what I would like to present today. So I would like to present two ongoing empirical projects I am working, and that are based on some ideas that started from the exam of this debate. So these are the two general idea on which the empirical studies are based. The first one is the difference between reconstructive versus preservative transmission. And the second is the difference and the different role of general factors of attraction versus local factors of attraction. I will explain now what this is about. Let's start from the first one, reconstructive versus preservative transmission. This is what we were mainly discussing in the paper with Alex Mesudi I am talking about. So what is the difference? Let's say, according to standard cultural evolution, what is important for cultural transmission is that transmission is faithful. So the idea is that humans are good social learners. Humans are better imitators than other animals. For example, various transmission biases act to ensure that the process of transmission will be faithful. So the idea is that a big part of the adaptivity of culture derives from faithful cultural transmission. Of course, there are errors. In my opinion, view of errors in standard cultural evolution is, if not the same, quite analogous to the idea of biological mutation. So errors are in general random. Error are for the majority of cases bad. So in general, if the process of transmission is not faithful, the trait that you will acquire will be not as good as the one you were trying to copy. But in the same time, error provide material for cultural evolution to create innovation. So in a very similar way in respect to biological mutation. This is a figure from 1 century old anthropology book from British anthropologist Pete Rivers, and which gave a graphical representation of this idea. These are Australian technological tools And so the idea here is that you start from a very simple stick that you see in the middle of the slide, and then through small modification due to a random error, from this single tool, you develop different branches, if you want, of artifacts. So from the simple stick, you go through the shield, or to the throwing stick, or to the boomerang, and so on. Again, in the paper with Alex, we use for the same example of preservative transmission, the example of baby names. Baby names are something that is studied quite a lot in cultural evolution, are a very, very common case study. I also did some work on baby names with Alex Bentley. Because it's relatively easy to gather quantitative data on baby names. So the idea here is that, again, cultural transmission is a process of hi-fi copying. It is basically a process of selection. So you in this case, for example, you look at the pool of existent names, and you select for any reason one of these names that is the cultural trait in question. You copy it. Copy is virtually error-free, and in the next cultural generation, you have a new instance of this specific cultural trait. So the name Lucia, and so on. So again, the basic point is that cultural transmission is a process of hi-fi reproduction of a cultural trait with some random error, generally deleterious. So this is the idea of what we called in the paper preservative cultural transmission. What about the other idea, reconstructive cultural transmission? This is quite a long quote from British psychologist Bartlett. Is considered the inventor of the transmission chain methodology that is today very, very used in cultural evolution experiments. And he was writing, talking about folk tales. When a story is passed on from one person to another, it undergoes many successive changes. Each event or incident in a narration possesses a certain potency of reproduction. The underpotent is omitted. The normally potent is reproduced. The overpotent is not only reproduced, but may so dominate all the rest as to change the whole course of the narration. So what is the idea here? So I gave now example of technological items or names, but let's think about another cultural domain. What is cultural transmission if you think about a story? So imagine someone tell you the story, say, of Cinderella. You want to copy it. According to the proponents of cultural attraction, what did happen is not that you are reproducing a similar copy of Cinderella because of hi-fi transmission. You are not copying the single words or anything. What they claim is that you are reconstructing a new version of Cinderella. This version will be similar to the version that you try to copy, again, not because transmission is faithful, but because some features of the story are particularly memorable, or are particularly easy to reproduce, are particularly attention-catching, and so on. For example, you will reconstruct, in the case of Cinderella, the feature of the pumpkin coach. The idea here is that the pumpkin coach would be a minimally counterintuitive concept. You're probably familiar with the idea. So Minimally counterintuitive concepts are concepts that are mainly consistent with our intuitive expectation, but with few violations. So in the case of the pumpkin coach, the coach is consistent with our idea of a coach. So the coach has wheels, transports Cinderella from the house to the castle of the prince and so on, but there are few violations. That is, it is in fact a pumpkin. According to some psychologists, these concepts are particularly memorable, particularly psychologically remarkable, and so the idea is that we will reproduce them in successive narration of Cinderella. One could say that similar cases, for example, for the presence of the evil stepmother of Cinderella. The idea here could be that living with step-parents is particularly relevant from the evolutionary point of view. So again, this would be a form of cognitive attractor. So to sum up, the idea is that the transmission chain of a story like Cinderella would not be a series of faithful acts of copying, but is a series of reconstruction of particularly strong, in this case, cognitive attractors. So the stability of Cinderella does not depend of faithful social learning, but depends on the fact that in the story, some features are particularly remarkable and particularly easy to reproduce. So this is the other idea of cultural transmission. In this case, a process that is reconstructive. Error in this case are one cannot talk about error in general because the process is itself a process of modification, but modification are not random. Modification are oriented towards this relatively stable attractor. The main argument of the paper with Alex Vesudi is that we don't see a necessary a contrast between the idea of preservative transmission and of reconstructive transmission, but we see these more as two extremes of a continuum. On one side, the transmission is purely preservative. On one side, transmission is reconstructive, and different cultural domain can be placed at different point in this continuum. So, for example, folk tales will be closer to the reconstructive part of the continuum. Technology or baby names would be closer to the preservative part of the continuum, and so on. So what we say is there's not a contrast, but might be an interesting way to think about different way in which transmission happens in different cultural domain. So starting from this idea, I want to present you the first of the two empirical studies. As you could suspect, is about folk tales. And this is a paper that I worked on this together with Jeremy Kendall and Jamie Terani in Durham. This is a submitted paper. We hope to have it published relatively soon. There is a preprint, so I invite you, if you are interested, to go and check. There are all the data, all the codes for the analysis, so you can have a look at everything. So, what's the story here? I have to do a parenthesis now to another debate in cultural evolution. This is the idea that there is a correlation between demography, some demographical feature, in particular population size and cultural complexity. The basic idea is relatively simple. The bigger a population, the bigger a group, the more complex is the culture that can be created and sustained. So big empire and big populations have more complex culture than small society. In an experiment, a group of 50 persons can solve a task that require cultural transmission better than a group of 5 persons, and so on. It's quite intuitive, but there is some debate in cultural evolution. We don't have to enter in the detail, but the basic idea is quite intuitive. And in the majority of cases, this idea is connected to some theoretical work made by Joe Henrik. Joe Henrik did a model. We don't need to enter in the detail of the model, but I just like you to explain the basic of this model. So in this model, individual attempt to copy cultural trait. They always choose the best cultural traits, the best model that is present in a population. But cultural transmission is error prone. And in general, the error will deteriorate the cultural trait. So this is a classic example of what we were calling before preservative cultural transmission. So in this case, transmission is good when social learning is faithful, and things go bad when so there is error. So in this graph that you see, the dotted line is the trait that individuals try to copy. In the majority of cases, that is the fat part of this distribution that you can see, that there is a probability distribution of where individual will end up when copying. In the majority of cases, they will end up on the left side of this distribution. They will end up with something that is worse than what they were trying to copy. And with the lower probability, that is the tail of the distribution on the right side of the dotted line, they will end up with something better than the model. So this is exactly the same concept that I was introducing at the beginning, talking about preservative transmission. The argument of Henrik, again quite intuitive, is that in a small population, it can happen that all individuals will end up with something that is worse than what they try to copy. So they all end up in the fat side of distribution. And so in a small population, complex culture cannot always be maintained. Sometimes iterating this process of transmission many times, the model showed that there is a dependence of the cultural complexity that can be maintained, and the total population size, the effective population size that participate in the process of cultural transmission. This is a very influential model, and I think is based on a very reasonable assumption. The story that tells is a good story. What I'm claiming is that is based on a particular idea of cultural transmission. That is this idea of cultural transmission being a process of faithful copying plus random and on average deteriorating error. So our question, what happens if we think that transmission is more reconstructive? So if you go back to this line, so this thing can work for technology, but what happens if we go in a domain that is closer to reconstructive transmission, like fault tails? So what we did was, in fact, checking. So we say, okay, let's check if in the case of fault tails there is a correlation between population size and cultural complexity. Our hypothesis being that because the process of transmission for fault tails is mainly reconstructive, we would not expect a relationship between complexity and population size. So basically, we would expect that small population have folk tales that are as much as complex as big population, and so on. So we checked, and we use 3 different measures of complexity. The first one is the number of tail types. So exactly, so a tail type is what you think about when you think about folk tales, so Cinderella, Little Red Riding Hood, and so on. And so in this case, we simply count how many different folk tales are in a population. The second measure of complexity is the number of narrative motifs. So here the idea in folklore studies, there is a lot of work that categorize the plots of folk tales as composed by some basic building blocks that can be present in different folk tales. So in this case, 2 examples here: a human marries an animal, a magic object is found, and so on. So the idea is that one folk tale can be represented as composed by a certain number of these narrative motifs. So for the first measure of complexity, we count how many folk tales there are, but then it could be that the population could have few folk tales, but then they are more complex because each of these folk tales is composed by more narrative motifs. And finally, the third measure of complexity is the number of traits in variants of the same type. So in a way, we zoomed in even more for 3 tail types for which we need data. So in this case, the idea is that, say, for Little Red Riding Hood, there are, say, 50 or 60 variants that are quite stable. And these variants differ. In some of the variants, the hunter rescued Little Red Riding Hood from the stomach of the wolf. In some other variants, this is not present. So again, we can count how many of traits are present in different variants, and we assume that a variant with more traits is more complex. So it's somehow a way to zoom in more in the narrative structure. So you can see this 3 measure of complexity as starting from a kind of coarse way of complexity of folk tales to one that is more going to the detail. Okay, these are some more specific of the methodology. So for the number of tail types, we use the Arne-Thompson-Utter index, that is it's basically the standard catalog of folk tales that is used by all folklorists in the last decades. And we focused on 2 of the categories that they isolate, that is animal tales and tales of magic, just because they are the biggest category. And we also focused on European and Western Asian data. This is because the European and Western Asian folk tales are summed more in the ATU index. So there are more European folk tales than African or North or South America. So we focus this to avoid or to limit at least the sample bias. This is for giving you an idea of the data. So you have a map, and each point represents the number of tales that we have in different areas. So they go from 10 to even less than 10 to 150, 200. As you see, Baltic republics are very present in the ATU index. And so yes, this is the first measure of complexity. The second, very similar. Again, the number of narrative motifs are provided in the ATU index. We focus here with a restricted sample that is only tales of magic. because in the animal tales there are less motives. Almost all tales in animal tales are made by 2 or 3 motives, while tales of magic there is more variance, is more complex. And again, for the same reason, we focus on European and Western Asian data. And finally, the last measure of complexity, 3 single tale for which we had data. So Little Red Riding Hood from Jamie Teran that is working with me at this paper. Polyphemus and the tale of the kind and unkind girls. So for all these, for these 3 tales, we had for each of these several variants that goes from around 50 the Little Red Riding Hood to I don't remember, but several hundreds for the tale of the kind and unkind girl, and for each variant we have a coding of the traits that are present or not. We really don't need to go into the detail of the model. It's just we basically fit the various measures of complexity with data of population size to see if they tend to correlate. And we did some control for excluding spatial and phylogenetic autocorrelation, that is to avoid, say, a small population as just a lot of tails because there was before part of the biggest population or something like that. So there are more or less standard way to control for this autocorrelation. Again, I'm very happy if anyone go and check if we did everything right or if we did something weird. The codes and the data are all public. Here are the result. So this is for the number of tail types. So again, if you remember, there were 2 samples here, animal tales and tales of magic. And we did found a relation between population size and complexity measured as number of tail types. So bigger population have more different tails. This is the second measure of complexity, that is the number of narrative motifs. And in this case, we found a negative correlation. So the idea is that bigger population have more tales, but in the same time, these tales are, their narrative structure is simpler than what happened for small population. So far we have 2 positive correlation and 1 negative. And here are the results for the number of traits in variants of the same type. So again, from left to right, Little Red Riding Hood, Polyphemus, and the kind and the unkind girls. In this case, we didn't find any relationship. So apparently there's no relationship between the number of traits in these variants and the population where the variant is recorded. And this is a table that sort of summarized the main result. So as I was saying before, a positive correlation relating the number of tail types, a negative correlation regarding the number of motifs, and no correlation for the number of traits. So, well, in the paper we discuss why we think that there is a positive correlation, which might be again a sampling bias. We discuss some hypotheses about the negative correlation for the number of narrative motifs. The only thing I want to say now is that if we look at this data, it doesn't seem that there is a consistent positive correlation between full tails complexity and population size, which is basically our starting hypothesis. So we concluded from this that, as I was saying before, we don't expect that there is a correlation between complex full tail and the big population. Complex full tails can be found with more or less equal probability in smaller population. Again, my point is not that there is not in general a correlation between cultural complexity and population size. On this, I am quite agnostic at the moment. My point is that this correlation may depend on the cultural domain and may depend on the different way cultural transmission act in these different domains. So I would expect that for technology, we live in a world that is similar to the world described in the Henrik model. And so there might be a correlation between complexity, technological complexity, and population size. In fault days, we live in a world that is not similar to the Henrik model, but is more similar to a reconstructive transmission world, and in this case we would not expect the existence of a correlation between demography, population size in particular, and cultural complexity. And this was my first study and the first idea. I don't know how we are with the time, but I guess I can have some more time. 20 more minutes. Yeah, that's probably even too much. The second idea. So I will give a quick summary also for myself. So big debate between cultural attraction and standard cultural evolution. I think the big debate is good. I think that what would be interesting is an integration between the cognitive, the more cognitive aspect that are put forward by cultural attraction and the more population dynamic style aspects that are put forward by standard cultural evolution. And I think that this debate can generate interesting empirical questions. One was related to different way in which transmission is thought, so in this case reconstructive and preservative. And one way to look at this is, but there may be other, and there are other that we are trying to work about, is to relate this to cultural complexity. Now a second aspect of this debate that we did really examined in the paper with Alex, but I currently think is even more interesting, and is the different importance that is given to what here I call general factors of attraction. General factors of attraction versus local factors of attraction to explain the success of cultural traits. I'm not really sure about the terminology. I might change it at some point, but the idea is that local factors of attraction are what in standard cultural evolution is called context-based biases. So conformity, copy the majority, prestige, copy prestigious people. So the idea is that in this optic, in this perspective, the success of cultural trait is not mainly due to the intrinsic feature of cultural traits, but is due to some contextual feature. I wear this blue shirt not for some feature of the shirt, but because I saw this in a movie, or because I'm copying, because the majority of my friends or colleagues wear the same blue shirt. And another way to explain the success of cultural traits is relate to general factor of attraction. In lingo of cultural evolution, this would be stable content-based biases. So say some lullaby that are shorter and with more rhyme, they will be easier to remember that long and not rhyme lullaby, so they will be more successful. I gave first example of other attractors. Say minimally counterintuitive concept will be stably more successful than other concept. the question that is quite simple, but I find it not really examined in cultural evolution, is how these two categories of factors interact. So in standard cultural evolution, it's not that they give more importance to local contextual factor, but they are more studied. So people like Boyd and Richardson or Henrik, they tend to repeat example about the importance of conformity or prestige. This is one famous example with that they cite in the paper or in the Not by Jeans Alone book. So they say why they pay billions to Michael Jordan to advertise underwear. So Michael Jordan is not he has many qualities, but it's unlikely that one of these qualities is being a particularly expert in fashion or especially in underwear. Why we copy Michael Jordan? So the idea is that is what they call prestige bias. So we tend to copy individuals that are we think they are prestige. The definition is a little bit more complicated, but it's enough for my point. And so we end up to copy the underwear of Michael Jordan. They do the same example also for more costly choice like kamikaze suicide and so on. So in this case, there's not any particular intrinsic feature in this underwear, but we copy it because it's Michael Jordan. Cultural attraction people, again, they would have to give more importance to the other side. So they will give more importance to stable, global factors of attraction or characteristic of cultural traits. This is a figure from one of the papers that I suggested as readings. And in this case, Dan Sperber and Lawrence Hirschfield give an example of this dynamic. So they say, okay, the universal success of cultural traits like mask or face makeup or portraits is due to stable cognitive attractor, is due to the fact that we have particular, our cognitive system is particularly attuned to process visual stimuli that looks like faces. And so mask, the cultural success of mask is not due to the fact that some famous people tell us masks are good, or is not due to the fact that everybody else does it, but it's due to the fact that they are particularly attractive. So here the question is, again, it's as I was saying, it's a kind of a simple question, but the answer is a little bit more complicated. Is what is the relationship between these stable, quasi-universal features and more local contextual cues? And I'm really starting to work more on this, and now I'm presenting a very preliminary study. And again, I'm doing it with Jamie Terani. In this case, we didn't even yet start to write the manuscript, so I'm happy to have any feedback about this. And here we started from a quite trivial observation, that is how like the online proliferation of famous quotes or various little memes with some nice sunset famous quote, and quite often apparently these quotes are misattributed, and so you say something quite silly and then you say, okay, Albert Einstein, and then people like it. Apparently we wanted to try to check this, and so yeah, the idea was, does the fame of an author influence whether people like or not a quote? And we thought that the answer to this question was clearly yes. So the second question was, does the domain of the quote modulate the influence? What does this mean? So we did, in this case, is an experiment that we did, and we took 60 quotes, 10 for each of these domains. So love, friendship, money, success, science, and literature. So here you have one example for each of the quote. We had 10 for each domain. And our hypothesis was that the influence of prestige would have been modulated by the domain. So we were expecting not much effect for love and friendship. So there's no much reason to think that Einstein knows much than me about love and friendship. Some more effort for money and success. So in this case, money and success are not the reason why Einstein is famous, but he is famous and he has money for sure, more money than me. So he would know more about this. And finally, the last domain is the specific topic for which prestigious people are prestigious. So if a quote is about science, in this case, we would have expected the effect of being associated with Einstein being even bigger. So 3 domains and check how prestige influence how we like a quote. So we took these 60 quotes. We took 30 famous names, and in particular 10 from humanities and 10 from science to match in the last domain, plus 3 random names. And what we did was an internet experiment, so we had quite a big sample, and what we were doing was simply ask to people to choose between 2 quotes. So like here you see an example. We have in this case the domain here would be success. So we have two of the 10 quotes taken at random. One is associated with some random Denver maker or whatever. This is a random name. And the second one is associated to Friedrich Nietzsche, which of course never say nothing succeeds like the appearance of success. And so we all this was paired randomly. And so in the end, we wanted just to count, okay, do people prefer quotes that are associated to Nietzsche in respect to Mikir, and in general to famous in respect to random author? And these are the results for the 3 domains. So love, friendship, money, success, and science literature. The red one is the proportion of time each of the 60 quotes were winning when was associated with a famous author. And the greenish blue box is the number of time quotes was winning when associated with these random people. As you can see, there was no effect. So people were not preferring quotes assumed to be said by Nietzsche, Einstein, or whatever more than other people. We were quite surprised by these results, and the first thing that we thought was like, okay, these people are just clicking randomly and they are not even reading what is going on. So we did a control. We did an experiment in which we were giving to people just the quotes without any names associated to it. And so we could say there is a relationship between the number of time a quote win when it's not associated with any author, and the number of time this quote was winning in this experiment. And these are the results. So the plot on the left is the proportion of wins in the experiment versus the proportion of times the quote was associated with a famous author. So each of these blue point is one of the quote. And as I already explained, there is no relationship. So being associated more with a famous author doesn't make a quote more successful. The interesting plot is the other one. So here the proportion of wins in the experiment is plotted with the proportion of win in the content-only experiment. So when the quotes were presented without author, and in this case there is a strong correlation. So the point here is that individuals were actually even in the when the quotes were associated to famous author, individuals were evaluating the content of the quote and not the fact that they were associated with a famous author. And this was for us quite a surprising result. We did a second study that has exactly the same structure, but in this case, we instead of prestige or fame, we check the effect of popularity. So in cultural evolution, there are two hypotheses about the effect of popularity. One that is a strong hypothesis, that is what is technically called conformist bias. So you might be familiar with this. The idea is that people, to be conformist, they should disproportionately prefer a popular variant. So if a variant is preferred by the 70% of your friend, you should have more than 70% of probability to copy these variants. There are quite a lot interesting reasons why so, but the only thing is that we were checking this hypothesis. So there is a disproportionate tendency to prefer popular quote, or a weak hypothesis, which was simply, okay, the quote that we present is associated with more people will be liked more, so a 50% effect. As I was saying, the structure is exactly the same of the previous experiment, but we were associating this time quotes with the number of you can say previous like, or number of previous, in this case, individual that choose the quote, and these numbers are of course made up by us. And what we were doing in this case was to give to a quote many previous vote, and to another quote many less. This example is quite important because this was one of the control question in which the two quotes have more or less the same number of previous like. So we had also this kind of control because we were fearing that people would get what we were trying to do. So there are some cases in which the two quotes are upvoted by the same number of people, or for the previous experiment, there were cases in which the two quotes were both from a famous author or were both from random people. Anyway, that's not super important. In general, one quote was preferred by 3/4 of people, and the other quote by 1/4. So we were saying quote A 300 and quote B 100, adding randomness and so on. Yeah, the result, this is about conformity. So as I was saying before, the idea is that people should prefer one quote more than the proportion of previous preference. If you see what I mean. So we were presenting always one quote being 1/4 and the other quote being 3/4. So we would have, if people were conformists, they would have preferred the popular quote more than 70% of time, and they would have preferred the non-popular quote less than 25% of the time. So our data should have been in this gray area of the plot. As you see, this is not what happened. So definitely people, the participants of our experiment didn't show any conformist effect. This is the weak popularity effect hypothesis. So this is exactly the same graph that I presented before for prestige, but not for popularity. And in this case, popular quotes were preferred. So popular quotes were in general more liked than quotes that were presented as unpopular. Not as much as being as showing compromise in the technical sense, but there was an effect on popularity on the choice of participant. Again, this is the same representation of the first study on prestige. So on the left, you have the proportion of wins versus the proportion of times the quote was popular. And there is an effect. So the more a quote was presented as popular, the more times the quote was chosen. But again, there is an effect, and it's more important, effect of the content. So popularity doesn't delete the effect of content. Even in this case, quotes that were highly voted in the content-only experiment are also winning often in the actual experiment in which we have popularity. So a very short conclusion of this experiment. We found, and we were quite surprised, I have to say, that the context in which we were presenting the quote, so if was associated to a famous author of was associated to many previous like is not really important. There is some effect of popularity, but not less than what conformity hypothesis would suggest. Apparently, there was not at all effect of prestige. But what is important is people seems to actually evaluate the intrinsic content of the quote. This is, of course, a very restricted case. We had a big sample, but it is a very is just an example. The point that I want to do is not some general point about the fact that the content is more important than context, but at least the contextual effects are not automatic. So we not just look at Michael Jordan and buy underwear, but things are a little bit more complicated. And with this, I think I'm done. This is a fake quote from Einstein, which is very common in the internet. Basically, that's it. So thank you for the attention, and I don't know if I should now go out from the presentation.
In this case, then probably you will be able to see us. Then it's good. Yes.
Yeah.
It makes not much difference.
Okay. Yeah. Okay. I can see.
Okay, great. So thank you for the We now have half an hour for discussion. There are also some people observing over the internet, and we already have a question from there, so we will include them as well. Just a quick rule that if someone else is already discussing and asking a question, and you think of a question to ask, you can already raise your hand, so we know how to distribute the time better, so we don't have to wait too long. Yeah. Okay. Who wants to start? Maybe I'll start. So I was wondering what the last study where where you were investigating internet memes with the help of experiments. So there is another way to do that, and I mean you have also written about investigating the internet and digital humanities approach to the digital culture. That still you choose to address it experimentally. So I'm wondering if you can explain your choice of Do you see that you could possibly complement the study with looking at internet corpora and how memes spreads? Can you look at the same kind of thing there?
Definitely. I see this as a first step. It's what I'm doing. So the idea was to use. Can you hear me?
I'm sorry, it's breaking off actually. Maybe. Yeah, can you try again?
Okay, can you hear me now better?
It seems to work now, yeah.
Okay, I tried to. Yes, so I agree definitely. This is what I'm starting to do now.
Mm-hmm.
So I was seeing this experiment as a sort of previous attempt to go into this direction with the advantage of having ability to control better for various variables. But yeah, the goal would be to do some more wide quantitative analysis of internet material. The experiment was very useful again because we had this subtracting data, and now I know what to. I have different questions I want to solve with the internet material.
So you want to address different questions with internet material?
No. It's the
just
same
the sound
one.
broke up, not partly, sorry.
Can you hear me?
Yeah, now I can again. I'm sorry.
Okay, I try. So no, it is what I was saying is that the internet material is what I wanted to do, and is what I'm doing now. The experiment was a way to start this in a way in which I had more control on my variables, and also gave me some ideas what to look in the internet. For example, before the experiment, I would not have looked for a content. I would have just looked for association with famous author. Yeah. Now I know in the internet study you have to take care of content, but the goal is to do internet study, yes.
I've also seen this kind of natural experiments in the internet where they create the fake Twitter account and they share memes or well, some kind of news with that. And then you can test these biases in a natural situation. So the other thing in the experiments was that it was a forced choice. So, yeah, so I think internet has much potential.
I tried to do some fake. I had some Twitter bots that were doing was just posting random quotes, and I wanted to see how many people would like these quotes. The problem is you need to have a lot of people interacting with these Twitter bots, and it's not easy. So the way I was doing was following some random people and see if they were following you back. And in the end, I had a lot of followers, but I think they were all bots basically. In the end, we were like, there was not really anything going on. So, but that's a possibility. Probably with a little bit more time and resources would be very nice to do something like that. Thank you. Thank you. We use, yeah, I didn't enter in the detail. We use modern data on population size and early 20th century estimate, because the idea is that ATU index collected late 19th century material, so they would have been more similar to the early 20th century population size. The other side, these are estimates, and they are practically perfectly correlated with the contemporary population size. So in the end, we use contemporary population size for the analysis. It depends. So we use in the ATU, they are defined as ethnic groups, but in general, they are so let's say Italians or Catalan, or we use the definition of the ATU index, and we just took population size for any demographic sources we had, and of course these estimates are open to plenty of problems. What I can say is that this is a general problem of all studies that link population size and cultural complexity. What we did was at least try to have different measures, and yeah, that's it. Yeah.
And as I know, because I studied some narratology on the some cognitive aspects of narratives, that well, narrative perception has kind of several layers. So, for instance, the surface layer of narrative, which consists of like words, then you have plot, you have story, and then you have like this deeper structure, and each of them is retained in memory for a different period of time, right? Like words are retained in memory really short, for a short period, and then plots are much longer, and then deep structure, like macro structure, is even longer. So, I mean, there may be no faithful transmission in case of the surface layer, but can be very nice, precise transmission on the deeper layer of narrative. So, what do you think about this hypothesis?
If you have a look at the paper with Alex,
Uh,
we write exactly what you say. It's perfect. I could not agree more. So the idea is, sorry, there is again a lot of echo, but it's exactly what you say. The idea that selection and attraction-based explanation could be both through a different level of analysis, and exactly we say exactly the same thing. So if we go at the level of words, one can model the selection process among words. If we go at the level of narrative models, can be a construction. But I perfectly agree. I think explanation. So one aspect is that some domains be more on the constructive side than the preservative, but also depending on the granularity of the analysis, one explanation can be better than the other. If this was your yeah.
Yes, yes. Sorry, I haven't checked this exact paper, so that's why.
What was not that? Just to say that it's yes, completely.
Oh, nice, nice to know that.
Yeah, it's we also do it. We give the example of say Dracula. So Dracula is the vampire is a big capital success.
On the stream.
Yeah. I find your question perfectly reasonable. We try. I mean, usually, as I was saying before, the study in cultural evolution about complexity use very simple definition of complexity. The study by Klein and Boyd about toolkit complexity in Oceanian island. I think they basically count the number of technological artifacts or the part they are made. We try to have at least like these 3 levels of definition of complexity. But of course, I mean, is one step in this direction. I would be very happy if people that know more than me and study folklore would examine better this question and say, okay, why not consider this other measure of complexity? Why one is better than the other? What are the relationship with this with complexity? I really do not claim that we solve the problem of how to calculate cultural complexity for folk days. I can claim that I would say that we did it slightly better than the other paper in cultural evolution because at least we tried different measure, but is really an open problem. I would be just happy if people would do something and even criticize and say, look, Acerbi and others did this, but it's better to use this measure of complexity for days. Great. Yeah, it's yeah. Yeah, that's also a possibility. So maybe one should go. It's interesting. I mean, one should say, okay, if we look, as you were saying, if we look at more complex form of literature, is there a correlation between complexity and population size? Yeah, that's interesting. I think it's a good question. I don't know the answer. I agree with you that it's a possible point. Okay. Do you have the video so it's easier for me to understand because otherwise, if it's not a problem,
What? Sorry.
if you can put your video and if I can see you, for me is easier
Yeah,
to
it's.
understand the question.
I will try to solve it quickly, but
Yeah,
I will just ask the question from the internet first.
okay.
But you need to maybe show your face. But this camera is not working.
Yeah, I think there's issues.
Okay.
But so the first question is from Natalie Tishkevich.
Yeah.
Why don't you think that your correlation between cultural complexity and population size is due to the fact that cultures of major ethnic groups traditionally have more elaborated descriptions? She's listening now on the internet too. So.
Yeah. Elaborate description of what? I'm not sure I understand that.
I think that she means that maybe they are just better described, that there's more information about them. And,
yes. Yes, I understand. So, like in the first measure of correlation, we found more tales for bigger population. And yes, I think that what she or he, I didn't understand, says is perfectly true. That's what in the paper. So if you want to look at the preprint, this is exactly what we say. There are the first correlation may be due to oversampling. I think that's true. Yes. So
Okay,
yes.
and that was the question.
This is the question. I would say I agree. It's probably because of better sampling, better description, and so on. Yes.
Okay, and the second question is from Chico Camargo. It has an introduction as well. So my question is also on internet memes being catchy. In biology, often we see one species copying another species strategy, either by actual observation, like birds do, or by some other mechanism. You can argue that similar things happen, for instance, online. Fake news websites and have the same design as real media vehicles. And if a Facebook page has a good strategy to get clicks, it will be copied. And that looks like biological mimicry to me. Can we use cultural evolution approaches to learn something more quantitative from this, beyond simply saying that looks like mimicry to me? I like these quantitative approaches to cultural evolution, but I'm curious about what we can do once we have evidence that certain means behave in a Darwinian way.
That's a fantastic question. I honestly don't know too much about biological mimicry. But I can see that this is an interesting analogy. I don't know. I think it's a very good point. And probably I don't know any work in cultural evolution that really thought about the mimicry analogy. So there is probably space to work about this. One thing that I'm trying to study a little bit more the literature about memes, trying to put it from a cultural evolution perspective. One interesting thing is that, which is similar to what to the question, is that memes tend to be, for how I see now, like templates for doing a lot of similar so one meme is not one thing in general. It's not one thing that is copied exactly the same, but it is a template for doing a lot of modification on a general theme. So like whatever you can think, Grumpy Cat is like you have the little picture and then you put a lot of different sentence on it, or so it is like a template that creates a lot of similar thing that was. I don't know if there is a relationship with mimicry with this, but I mean, I think it's that there is a lot of things to do. The problem is that the analogy with biology are always interesting and in the same time a little bit risky. So one has to be a little bit careful about if it's useful to talk about some cultural phenomena in terms of biological mimicry or not. But for sure is interesting at least to explore.
And I have a follow-up for this. That do you think that studies in culture evolution could contribute to studies in biological evolution? Importantly.
Well, what do you think?
Yes, I think so too.
Yes.
It's a loud yes from this room.
I want to know more.
Well, culture evolution is, for example, it seems less constrained. And in this sense, maybe the theories that you describe it can be more general and can be applicable to more general cases, for example.
Yeah.
While also I find it possible that maybe cultural evolution could be more easier to understand for people rather than biological evolution. So maybe in the future they would teach cultural evolution in school as a model for biological evolution. But
Well, that's, I mean, it's fascinating. It's also very complicated matter. I mean, I would like that they would teach cultural evolution at school. Not necessarily for as a model for biological evolution, but because I think that is by itself a better way to understand human dynamics. It's a very difficult question. I mean, I tend to have, as I was saying before, to me the analogy between cultural and biology are always. I mean, I think that there is some interesting way to think about evolution in a more abstract algorithmic way, and then you can apply this to culture as much as biology. So in this case, I think it's a good exercise. In the same time, I'm always like, okay, when we talk about cultural selection, is just a metaphor, or there is something meaningful. It's interesting, and also is also difficult. I mean, one should be careful, but it is really good to do. I'm a little bit skeptical about. Is this in streaming in the YouTube?
Yes, I believe so. Yeah.
Okay, then I stop here.
Oh, okay.
So let me comment a bit this last aspect, relationship between cultural and biological evolution. If you gave this couple of examples from Pitt Rivers scheme and Bartlett's in the beginning of your talk, I would clearly see that these were influenced by biological models. Say the biological, well, Darwin's idea of evolutionary tree, well, you could see that the idea of importance of reproduction, clearly these came these views were influenced by Darwinian models, I think, very much, say, biological ones. And say that even we could think that this has been pretty damaging or not good influence for a long time, because otherwise, if the influence from cultural sphere to biology have been stronger, the whole of biology would have had a better theory, I would say. You know, there is some pretty important saying that these Darwinian models excluded or life itself from their models. So, while cultural evolution never forgets that this is living, what's going on. So, therefore, I think you as anthropologists should be brave enough to suggest to biology your results, I would say.
I mean, that's true. I mean, there is now, I'm sure you know, and you probably know better than me, a big movement about the new thing, not new things, about the project that people like Kevin Leland are doing about a different foundation of evolutionary biology, and they are for sure influenced by cultural evolution. I honestly, I could discuss about this, but it's not my knowledge is pretty limited. To me, the main interest coming from an anthropological side, I was at the beginning fascinated by the fact that, I mean, I had kind of the opposite path. So I was fascinated by the fact that biologists were doing science. They were observing pretty complicated things, and still they were arranging a way to do some quantitative modeling. And to me, this was very like, say, wow, we should do the same for culture. So still for me is I'm kind of a more on, if you want to use this word, the reduction part of science. So I want to make culture as the cultural explanation as quantitative and models like as biological explanation. Of course, it is fascinating to think at the other possibility. It's and I don't know if I would bet it would probably happen something like this, but I really don't know.
Also, I had a quick question. It seems not a question, but a comment regarding how cultural evolution can impact biological theory. Actually, Kevin Laland's and Alding Smee and Feldman's theory of niche construction probably is exactly the example which is at least inspired by cultural evolution. So humans build cities, they change their environments, and from this insight, we can then look back into the biology and notice the same process in a lot of variety of different species and living forms. So exactly.
Yeah, and second, I'm looking for how are they called now? Yes, so Kevin Laland and all these people, they have this new huge project about extended evolutionary synthesis, and I think that they are doing exactly this thing. Again, I am interested observer in this and not anymore. I can really say, okay, looks interesting. There's not much I can say about this.
There is one quick follow-up from Chico Camargo still.
Yeah.
So knowing biological evolution has led people into trying to engineer biological evolution. Do you think that we can engineer cultural evolution?
Yes, we can, and I mean people they do it. I will advertise a book that I was reading.
We see it. Yeah. Aha.
This is a kind of classic anthropology book, kind of ethnography about machine gambling. For me, the very interesting part is about exactly how, in this case, the cultural fitness of all these tools, the various machine, the various game are is actually engineered to make them more culturally fit. So there are a lot of nice examples in which. Now I have to remember. I wrote a blog post about this because I was really fascinated when I was reading it. So for example, that you want to in the electronic slot machine, you have to put fake winning sign close to the one that are coming to the person that play can see. So in this way, they will be more attracted to play with this machine. So I think you can if engineering means to act explicitly on cultural traits to make them more fit, I think this is happening. It's interesting to think about it in term of evolution again. So probably we are not thinking about it in terms of evolution, but I mean, I think in general we do an effort in making cultural traits for which we care, make them spread more than other. And I think this is engineering. It is not made always with consciously, but in some case, like in this case, it's made consciously. So that's why it's interesting. But yes, I think so. Again, it is interesting to look at it from an evolutionary point of view. This we are not doing.
One more little question about your first study. Say where I was asking what do you mean by population? But haven't you tried to study correlation with instead of or in addition to population size with population density? because population density would really say something about, say, communicative aspects and maybe hints to a real a mechanism what can be behind there instead of population size. That means population density. Why not that?
Yeah, no, that's definitely that's a good point. We kind of followed the standard ways done in the previous study of cultural evolution, but yeah, that's absolutely a good point. One can check different measures. Yeah, that would make sense. Yeah, thank you.
Thank you. And also the people on the internet, they thank you for the comments and for the answers. They were really
Thank
great.
you to the people of the internet.
Yes, so Chico Camargo and Natalia
Sure.
Tomasco are watching us from a live stream. There are a couple of more people watching, but they didn't announce themselves. So thank you.
Thank you to you. It was a very intense 2 hours.
It's good to hear. Yes.
And really good. Good that you are doing these seminars. I think is really good to spread the cultural evolution around. We are still a very small minority, and we should engineer cultural evolution to get better. So let's do it.
Yeah, it's a great idea. Yeah. Thank you.
Bye bye. Thank you.
Yeah, so thank you again everyone for coming, and next time Professor Kaleikov will give his talk. So everyone is warmly welcome.